Welcome to MarkLogic University's tutorial, Introduction to JSearch. This video is a series of topics regarding features and functionality in MarkLogic's JSearch library. You will learn about JSearch, which adds powerful, higher-level search features and best practices to MarkLogic's server-side JavaScript. The target audience is developers using MarkLogic's server-side JavaScript. A fundamental familiarity with MarkLogic is assumed. Additional details about these concepts can be found at http://docs.marklogic.com. The following topics will be covered in this tutorial. What is JSearch? JSearch top-level methods. JSearch design patterns. JSearch features. The code examples presented are available for download from MarkLogic University GitHub repository at https://github.com/MarkLogicUniversity/JSearch. What is JSearch? JSearch adds powerful, higher-level search features and best practices to MarkLogic's server-side JavaScript. This is the first place developers should start when doing searches, and still allows developers to utilize lower-level APIs if needed. Not only will the API save experienced MarkLogic developers keystrokes, it is engineered for performance at scale and uses familiar JavaScript idioms. JSearch features include searching document contents and properties, including documents, snippets and/or facets in results, applying content transformations, and returning subsets of results in configurable slices. You can generate facets for arbitrary sets of documents. You can query lexicons and range indexes, finding values and tuples, and also computing aggregates over these values and tuples. The following represent the top-level methods in JSearch. Collections. Create JSearch objects scoping all operations to specific collections. Documents. Search documents and document properties. Create document projections and snippets, and retrieve metadata such as relevance scores. Values. Query values in a lexicon or range index, optionally computing aggregates over those values. Tuples. Find n-way value co-occurrences in lexicons and range indexes, optionally computing aggregates over the co-occurrences. Words. Query values in a word lexicon. Facets. Generate facets from a value lexicon. And document select. Generate snippets, extract parts of documents and/or a set of similar documents from an arbitrary set of documents, such as the result of calling CTS search function or fn.doc. This tutorial will focus on the documents top-level method. Query design patterns. Document search, lexicon values, tuple queries use a pipeline pattern. The pipeline mirrors steps MarkLogic performs evaluating queries. Pipelines can include steps such as query criteria definitions, results ordering, and result transformations. There are four main pipeline steps for building and evaluating queries. First, select a resource such as documents, lexicon values, tuples, etc. Add pipeline stages that define queries and desired result sets, such as query criteria, sort ordering, and transformations. Specify any desired advanced options, such as quality weight. Perform the operation and get results. This is an example of a JSearch pipeline design pattern. Select the resource to work with, such as documents or lexicon values, using one of the top-level methods. Optionally, subset the results with a query. Specify result set refinements such as sorting, slicing, or transformations. Perform the search operation and get the results. JSearch method names are similar to those found in SQL and JavaScript standards. The .where, .orderby, etc. provide the same functionality as in SQL. The .slice method has the same semantics as JavaScript array slice methods. Let's look at some JSearch basics. To do a basic document search using JSearch, begin by importing the JSearch library functions by including a require statement. Use the top-level documents method and return the results. This returns all of the documents from the database since there was no where clause to constrain them. The query can be scoped to one or more collections using the top-level .collections method. In this example, we would use the returned classics variable instead of the JSearch object in search calls. Call the top-level documents method to select documents as the resource to be queried. At the minimum, this selects all documents in the example database but constrained to the classics collection. The search can be further constrained by using the JSearch where method, similar to the where clause in SQL. Queries can be created with query by example search criteria. QBE can rapidly prototype searches for, quote, documents that look like this, end quote. QBE queries are similar in design to SQL query by example. Complex queries can be created quickly and easily, especially for developers familiar with QBE in SQL. Query strings. Query strings are useful for capturing user input in string formats, such as from a text box on a web page. These strings are then parsed to appropriate MarkLogic query methods. One or more low-level CTS.query methods. These give the developer the most control over search and are especially effective when complex searches aren't possible with any of the other techniques. Mixing and matching any of these. Flexible queries can be a mix of the string, query by example, and CTS.query methods in the same search. For example, combine a CTS query to AND the results of multiple QBE queries, then combine those results with a MarkLogic geospatial query. Let's look at examples of each of these approaches. Using JSearch's by example method, we create searches by using parts of the document as examples. This example uses the author property of the JSON document to constrain the search to only authors that are equal to the string Mark Twain. The results of the search are listed below. Deeper queries can be composed utilizing ANDs, ORs, and searches over ranges of values. This query finds all books in the database with a price less than $10 and a price greater than or equal to $8, and the successful results are returned. Using query strings. JSearch can use strings to define the search criteria. Examples include dogs and cats, but not fish, to search for documents that contain dogs, the term cats, but not the term fish. Terms are stemmed to their root words, so documents that contain dog, but not dogs, will still be found. This example searches for the term Tom or the term Huck within documents in the database. The function CTS_parse is used to parse the string to MarkLogic's core search functions, providing interoperability with other functions. Running the search, we retrieve the results. This example uses a reference tag named price that is bound to an index on the price JSON property by using the CTS.json property reference function. Tags create a new label for an element or JSON property that is indexed. The search returns all books in our example database as a JSON property called price, and where the price value is less than $10. Tags can be created as one-time references, or they can be reused. In this example, the tag of buy is created in a variable, so it can be reused in subsequent searches. The by tag is another label for the JSON author property. Thus, it becomes part of the search grammar. And the results list down all books that has an author, or by, Mark Twain. Searching can also be accomplished by using MarkLogic's built-in cts.query methods. Use the built-in cts.query methods to search based upon more complex criteria. This example demonstrates using a cts.json property word query. We're searching for the author JSON property that contains the phrase Mark Twain. The results display the documents where the author is Mark Twain. Various cts.query methods can be combined to build more complex searches. This example creates a query that matches documents in the database directory books that contain the phrase Huck or Tom in the title and have a format JSON property with the value of paperback or a JSON property price that is less than $10. Only one document has matched our criteria. Apply further refinements to the results set, such as sorting the results or slicing the results into subsets. The default sort order is by relevance score, ordered descending. Other sorting criteria can be specified by using the order by method. In this example, the sort is by a specified JSON property of title. Sort criteria must have range indexes defined. Here we see the results, sorted by title. Sort order can be controlled by using one of the cts.order methods. In this example, we are using a cts.indexOrder to sort by title and order them ascending. In addition to cts.json property reference, other reference can be used to control sort order, such as a cts.element reference, cts.field reference, and cts.path reference. Each of these references must have a range index defined. The results display the documents sorted in title ascending order. Sorting can be on multiple keys. This example sorts by price first, and then by title. When the code is run, we can see that indeed they are sorted by price, and if the price is the same, they're sorted by title. Slicing is another refinement that can be applied to return subsets of results. Slicing in JSearch is similar to applying a slice to a regular JavaScript array. The first argument of the slice is the first position to return. The second is the last position to return plus 1. Positions are zero-based. Running this example, we return back 2 results, but the estimate is 4 documents matched our query. Only 2 were returned because of the slice. To return only metadata from a search, specify a slice starting and ending positions of 0. In this example, although the results are null, no documents returned, the estimate shows that 4 documents would have met the criteria. The .result method at the end of JSearch is used to execute the search and receive the results. Document results are returned in an array of JSON objects, each representing a query match. Document node can be accessed by iterating through an array of JSON objects, returning the value of the .document JSON property. MarkLogic nodes represent nodes in the database and are immutable. Use the nodes.toObject method to return a mutable object. This example shows the results of a document search for book authors containing the word Twain. The search library is included. JSearch.collections returns a convenience method in order to constrain any search by specified collections. JSearch.byExample adds another convenience method for flexible query by example searches. We're setting our query by example to the author property that contains the word Twain. We're constraining our results by the collection of classics, finding documents that match the QBE specified earlier, authors that contain the word Twain. .result executes the search. Store the search results in a variable. We're using query return. The results are returned in a property called .results. The value of the results property is an array of search results. Iterate over the results returned, if any. For each result, we're retrieving the document's URI. MarkLogic URIs represent each document's primary key in the MarkLogic database. We also get, from the .document object, each query results node. This represents the node of the document in the MarkLogic database. It is immutable. We can use the toObject method in order to make that mutable in case we want to apply any changes. In this example, we're updating the author property to a new value, m.twain. We're adding the changed document to an array. Then finally, we're displaying the results of that array. You can also update information in the database. For example, let's say that I want to take my changed document and store it in the database with the same document URI, thus updating the document in the database. We can use the xdmp.documentInsert method, supplying the same URI as the one in the database, our changed document, applying any permissions that we want, and also possibly using the same collections as the previous document in the database. Running this code displays all of the changed documents, showing the author updated to m.twain. In this video, you learned what is JSearch, JSearch features, JSearch top-level methods, about the JSearch design pattern, how to search for documents with JSearch. Code examples are available on the MarkLogic University GitHub repository at https://github.com/MarkLogicUniversity/JSearch. Thank you for attending this MarkLogic University on-demand course. Please visit mlu.marklogic.com/on-demand for a complete selection of on-demand topics.